Today we're going to learn how to do shorthand or noble gas core configurations. So the first thing that we need to know is that the noble gases are the elements that are in the last column of the periodic table. So that would be helium, neon, argon, krypton, xenon, and radon. And so we're going to use these noble gases to shorten our electron configurations for elements. The reason that we use noble gases is because noble gases come at the end of each row. And so what that means is that we have completed an energy level with electrons. And then when we go down to the next row in the periodic table, we have started a new energy level. And so noble gases are a convenient thing to use to shorten our electron configurations. So to get started, we're going to write two electron configuration notations. And so we're going to write the configuration for magnesium. Magnesium has 12 electrons. Its atomic number is 12. So we've got a neutral atom, so we have 12 electrons. So to write the electron configuration, as we always do, we're going to use the Aufbau principle or diagram. And so remember that we have to put electrons in the lowest energy sublevels, and then we move on up to higher and higher sublevels as we go. So for magnesium, we're going to start at 1s like we always do. And an s sublevel with one orbital can hold 2 electrons. And then 2s comes next according to our Aufbau diagram. 2 electrons can go there. After 2s, we have 2p. P sublevels have 3 orbitals, so they can hold 6 electrons. Now we've added 10 electrons to our configuration, and so we need 2 more. So we have to go to the next sublevel, which is 3s, and we can put 2 there, and that gives us 2 and 2 and 6 and 2. That's our 12 electrons. Now, the next thing I want us to do is we're going to write the electron configuration of neon. Neon's a noble gas, and I picked this one for a reason, but neon has 10 electrons. And so if we write neon's configuration with its 10 electrons, we're going to start at 1s2, then 2s2, then 2p6. And there's neon's 10 electrons. So if we compare the configuration of magnesium to the configuration of neon, what do they have in common? Well, they have neon's whole electron configuration in common. So in other words, magnesium is neon's configuration plus 3s2. And so we can shorten magnesium's configuration by using neon, and we're just going to put the element symbol of that noble gas in brackets, Ne. That means 1s2, 2s2, 2p6. That represents the electron configuration of neon. Then we're just going to add on the additional electrons that magnesium has, and that gives us magnesium's shorthand configuration. So, obviously we don't want to have to write all this out every time. So we can figure out, using the periodic table, how to do a shorthand configuration for any element. So here's what we're going to do. let's say that we want to write the shorthand configuration for potassium. So potassium's right here. It has 19 electrons, and so what we want to do is we want to represent as many of those 19 electrons as we can by using a noble gas. And so we always want to use the noble gas that precedes that element or comes right before it. So here's what we always want to do. To figure out your noble gas, find your element we're going to write the configuration for, in this case potassium. We're going to go up one row, and then we're going to go all the way over to the right until we hit our noble gas. And so for potassium, to do potassium shorthand configuration, we're going to use argon. And so that means then, if I'm going to do potassium with its 19 electrons, that I'm going to start by putting AR, my noble gas symbol, in brackets. And so argon, this noble gas, has 18 electrons. And so if we wrote that configuration, 1s2, 2s2, 2p6, 3s2, 3p6 would be its configuration. And so we have eliminated having to write all that out, because when we write this, that means argon's electron configuration. So we know that potassium has 19 electrons, argon has 18. So we know that potassium has one more electron past argon. So we have to write that in. And so the way we're going to do that is we're going to go back to potassium, and we're going to look at what row or period potassium is in. Potassium is in period 4. And so we're going to start with energy level 4. And then when you do one of these shorthand configurations, you're always going to start at the S sublevel. So we know that we have to put the additional electrons, we have to start with the 4s sublevel. Now, potassium has one more electron than argon, and so we only have to put one electron there. That's 18 electrons, plus this one gives us potassium's 19, and that's all we have to write out. So let's try another one. Let's say that we want to do, let's do 10, Tin, the element. So Sn is the element we want to write the configuration for, and it has 50 electrons. Now, if we were having to do that whole configuration, that's going to take a while. 50 electrons is a lot to have to put into sublevels. So it's a lot easier to do the noble gas configuration. And so how we're going to do that, remember, you're going to look at your element, 10. You're going to go up one row and all the way to the right, and that gives you which noble gas that you're going to use. So we're going to take that noble gas, and we're going to put it in brackets, Kr in brackets. And remember that that represents all the electrons that krypton has, which is 36. So instead of having to write out all those sublevels for all those 36 electrons, that's all we have to do. So the next thing we need to know is, well, we have to add on the additional electrons that tin has. And so krypton has 36, tin has 50, and so what's your difference there? 50 electrons, there's 36 that we've already accounted for, so that difference is 14 electrons. So in other words, I need to add on 14 more electrons to reach tin's configuration. So I'm going to have to figure out where to start, what sublevel to start with. And so I'm going to go back to tin on the periodic table. I'm going to go all the way and find what row it's in. And it is in row 5. And so what that means is I'm going to pick up with 5 and then it's always going to be an S. I'm going to pick up with the 5s sublevel. And so I'm just going to add on now my additional electrons, starting with this 5s. Remember, I've got 14 electrons I need to add, so I can put 2 electrons in a 5s sublevel. I've got 12 more to add now. So what comes after 5s? Well, we're going to have to go back to our off-bow diagram. We're right here, 5s. That's at the end of that little road. So we're going to go to the next road, and we're going to be at 4d. So we can add the 4d sublevel next. A d sublevel has 5 orbitals, so 10 electrons. And then I still need to add a few more. So after 5d, 6p is next. And so 6p. And then remember, I was trying to add on 14. So there's 2 and 10, that's 12. So I only need 2 more. And so 10's shorthand configuration is Kr 5s2 4d10 6p2. 36 electrons here, plus 2 plus 10 plus 2 gives me 50 electrons. All right, and then let's try one more just to make sure we've got the process down. So this time, let's do, we'll do phosphorus. All right, so if I want to write the shorthand electron configuration for phosphorus, phosphorus has 15 electrons. And so to do the shorthand, remember, I want to know which noble gas to use. I'm going to go up one row and all the way to the right, and that gives me neon. So I know in my shorthand configuration for phosphorus, I'm going to start by putting neon symbol in brackets. Now neon has 10 electrons. I need 15 to be phosphorus. And so what's the difference? Well, 15 minus 10 is 5. So in other words, I need 5 more electrons added onto this to represent phosphorus. So I have to know which sublevel to start at. And since neon already, those 10 electrons have filled up 1s, 2s, and 2p, actually, to figure out what sublevel to pick up in, I'm going to go back to phosphorus. I'm going to go all the way and figure out what row it's in. And so phosphorus is in row 3. So I'm going to start at the 3, and then it's always going to be S sublevel. So how many electrons can I put there? Well, since S sublevels have 1 orbital, I can put 2 electrons. Then I'm going to need to add some more, because remember, I needed to add on 5 more. So what comes after 3S? Well, 3p comes next. And so I'm going to go to the 3p sublevel next. And I only need 3 more electrons. And so Ne 3s2 3p3 is phosphorus shorthand electron configuration. So 10 electrons are represented by neon. That's the first 10 electrons in phosphorus, plus 2 plus 3, and that gives me my 15. So that's how to do the shorthand or noble gas core configuration.